Okay, we're going to take a quick look at that 2-1 through 2-5 review. We'll just do the first, I guess, page on this video. Hopefully it won't take very long. So let's see how this goes. We started off with actually a very old review question, just going over vertex form, because I've noticed we have a lot of people are really kind of struggling with this idea of vertex form. So in your days back in I guess it was math too. You learned this little formula, which was using opposite b over 2a to find our axis of symmetry. So in this particular problem, if I was going to do opposite b, that would be opposite of -8 is +8. And if I double 3, I get 6. So I got 4/3 would be the value of that axis of symmetry. Now, as it turns out, this problem is kind of written out of order, but there's a reason I did. But if you were to go back to the original problem and everywhere you saw an x, replace that x with a 4/3, this would give me the y component of that. So keep in mind, you start off by finding your opposite b over 2a, your 4/3, and do that. Now, doing a little bit of arithmetic on this, 4/3 squared is 16/9 times 3. 16 over 9 times 3 is actually 16 over 3 minus 32 over 3 plus 21 over 3. I'm just making a quick common denominator. One of the little reminders back from math too that we learned is that every single time, if your line of symmetry is correct, these two numbers are always in a 2-to-1 ratio, which is kind of helpful. So if we put this all together, I've got 37/3 right here with the positives, minus 32 is 5/3. So that would give my vertex at x equals 4/3 and y equals 5/3, which means I could write my equation very quickly because it got shifted 4/3 to the right and down 5/3, but it has a leading coefficient of 3 from right up here. So, we could have done a very formulaic approach to that, or we could use the version that I have gone over a few times with you guys, called completing the square. And it's just the one that I personally prefer. And so what we did in here is we factored out that 3 out of both of those pieces and left the 7 just hanging. We took this value right here, half of 8/3 is 4/3. And if I squared that, I got 16/9. But see, that's really a fallacy because we didn't add 16/9. We actually added 16/9 times 3, which is 16/3. So I need to take 16/3 away from both sides. And so we end up with half of 8/3 is 4/3. That's why we did what we did right there, is so that when we completed that square, we would have this perfect set of factors. And 21/3 minus 16/3 is 5/3. That's why I kind of like this version. I find it is a lot more efficient, but they both work. And if that bothers you the other way, you have another option. Okay, now we're going to do a little bit of graphing by transformation. Again, this is a review, but we do have a final exam coming up, and I don't want us to forget all of the little pieces that we've done. But we had a rule that we never want to have anything attached directly to x. And in this case, that 2 was directly attached to x. So we've got a couple of things going on. This is going to multiply all the y values by -2. This right here is going to divide all the x values by 2 and then subtract 3. Remember, these things are going to do the opposite of what they say. This is going to do exactly what it does. So where a was -4, -2, and b was -2, 0, and c was 7, 3, what we want to do is first, let's take all the y values and multiply them by -2. So that's going to be 4, 0, and -6. And for all of the x values, that's opposite land. I'm going to cut it in half. So I got down to -2. And then I'm going to go to the left 3, and that's going to get me to -5. Here, I'm going to take the x value, which is -2. I'm going to cut it in half, which gives me -1. And I'm going to shift it to the left 3, which is -4. And last, I'm going to take the 7. I'm going to cut it in half, which is 3.5. And I'm going to move it to the left 3, which gives me 1/2. So that's kind of how that's going to work. And I think that's all we need to do what we have. It says given the graph of f, graph the transfer. Oh, it wants me to actually transform this thing. So let's go ahead and finish that up. So I guess we could put a prime at -5, -4, 1, 2, 3, 4. I've got -4, 0, which would be here. I feel like I did something wrong. Oh, -5, +4. That was silly. -5, +4 up here. -4, 0. And then I had my other point, which is 1/2, -6, which is down here. Now, this isn't a great graph because we don't have all of the bells and whistles, because there's one extra point, which is point D, that would have been helpful to do, but it turns out D, if we graphed this point right here and transformed it, we would get, I believe it's this one right here. So this is really the transformed graph of that. Really, I only asked you to graph these three values here of A, B, and C. Anyway, moving on. Using only algebraic method, we're going to find the cubic function that does all this. So what I know is that I have function f of x that has, if I plug in 3, I get 0, which means that's a root. And if I plug in -2, I get 0, which is another root. And if I plug in -1, I get another 0. That's another root. Now, the only problem is we get to this 5, and you're like, what's that? Well, that's just a random coordinate. So what I know is that there must be some kind of a leading coefficient there that makes this work. But I want to say that if I plug in 5 minus 3 is 2, 5 plus 2 is 7, 5 plus 1 is 6. So I have A times 84, I believe it is. 7 times 6 is 42, times 2 is 84. And somehow that number is supposed to be 21. So if I divided both sides, I'd get a quarter. And therefore, I've got my function that f of x should be 1/4 of x minus 3, x plus 2, and x plus 1. And because the problem didn't specify that it has to be in standard form, we can call it good. So hopefully that was helpful. That was the first 3 questions, and I'll see you back in class. Bye-bye.